So as you can see, these are the different cases or where we use queue. And so if you're designing one of the system like a online grocery system, banks, airport security, okay, so you should actually have the knowledge of queue as well. In case of web development, file management, FTP, database, mail, printers, and so on. So let's see some of the use of queue in computing. So first of all, in simulation studies where the goal is to reduce waiting times, we use queue. So how it works, it optimizes the flow of traffic at a traffic light, okay, or it can be determining the number of cashiers you have to have on duty at a grocery store at a different times of the day, because we know the load of the customers are not same. Okay, like at the morning a very few customer goes to actually a market, but at the morning a lot of people go to the grocery store to do the actually bazaar or the shopping, and then at the night people go to the shopping centers. So the number of cashiers you have to have on duty you can also determine from the queue. Also consider an information center. In that information center, okay, people call for different information. So how many calls you will arrive at random intervals, and if the, you see, whenever you call to a customer care, what happens if less all the customer care operators are already in a conversation, you are actually told to please wait, our customer caller is busy, please wait. So you have already seen it, right? And these are actually real life implementation of queuing system. Okay, so whenever you call for the customer care and if the operator is busy, okay, they will actually send you to a queue and you have to wait there. So you'll be placed in a queue for incoming calls, and when the agent becomes available, whoever is waiting for the longest amount of time will go, you'll get the agent first. So these are some of the uses, and you see here this is an actually a like a representation how queue works. So this person, the red, okay, he is actually joined at the last of the queue, and suddenly this queue started moving, and then again he's actually confused, like where should we go, should he go to this line or should he go to this line, and he's actually keep confusing like what should we do. So this is an funny example of queue, that sometimes whenever you switch queue it's not always good. So anyway, let's move on to the second. So the one of the first use of queue have been found in coded message. So what is a Caesar cipher? Let me give you a short idea about the Caesar cipher. So let's assume that you have a message. Okay, the message is, let's assume that I am Sakib. Now let's assume that this is a very you don't want anyone to read this message. Okay, so what you decide that you will actually code the message. So what can be a code? So let's assume that you use the cipher code. So what, how it works? So what it does, let's assume you have A, B, C, D like this. So what this code does, okay, with the value of k equals to 1, it change A to B, B to C, C to D, D to E, E to F. Again, if the message is A, B, C, D, E, and if the value of k equals to 2, okay, what it does, it actually changes k, it changes A to C, B to D, C to E, D to E, F, F to G. So you see what's happening here. When the value of k was 1, okay, I have shifted each word to 1. So A became B, that means one letter after A, B became C, C became D. Okay, when the k value of k was 2, A became C, that means it became 2 letter after the A. So if I want to apply this one same here, okay, so if let's assume the value of k is 1, okay, so this message, that is my name, I am Sakib, I will become J, A will become B, then M will become N, then S, what is the T, B, L, J, C. So see,
Sure.
so the message will actually change. Now, it was easy to read, I am Sakib, but can you read this now? No, like it becomes difficult. So this is one example of Caesar cipher. So what happens that whenever you have a message like this, we use the substitution code, and using the queue, you can actually easily encode and decode the substitution queue. So what? So you see, initially it was very easy. So it was very easy to break the code. Okay, so the code was easy to break. Okay, so Then what happened, they actually found out another way. So instead of using one single key, that means k equals to 1 or k equals to 2, what you can do, you can actually use multiple key. So 317425. So what does this mean? That means the first letter will be shifted 3, the second letter will be shifted 1, the third letter will be shifted 7, the fourth letter will be shifted 4. So that means we are using multiple values of k. Now it actually becomes difficult. If I ask you that using the same code, please decipher I am Sakib, it actually becomes difficult because you multiple time you have to look. So instead of doing it on our own in computing, what we can do, we can use queue. So what the queue will do, okay, the queue, what it will do, so it will get the message like this. The encoded message will be like NA, NO, VN, GJ, MU. So it will not make any sense. But if you use the key 317425, again 317425, 317425, you see the key is repeating itself. Okay, 317425, again 317425, again 317 until the message ends. And if you actually use the key, then the message becomes knowledge is power. So you see, this is a very message. So what we do, we actually use a queue here. So first what we do, we use the key, we EQ the key, and after using the key, we dequeue and again EQ it back. So basically what happens, that let's assume this is my queue. So what we do, we first see what is the front of the queue. So we have 3. So what we do, we actually dequeue this 3 and push it back or in the last of the queue. So this goes on forever. Then we actually this one, and then we again push it back. We actually dequeue this one and again we EQ this. So what happens, that these values 317425, they actually, that's why they keep repeating this themselves. Okay, because we just take one and we again push it back. Okay, or we EQ that. So we do the dequeue operation and we do the EQ operation, and that's how we can use this EQ DQ technique in encoded messages as well. Then we have the implementation in single linked list and circular arrays. So we'll see these two later.